Class 8. Assalamu alaikum wa rahmatullahi wa barakatuhu. Welcome back once again to your chemistry online class. In my last lecture, I had started with lesson 8, water. Let's quickly recapitulate what all we had done in the last lecture. So I told you that water covers nearly 2/3 of the Earth's surface, and there is no life which can exist without water. Life is not possible without water. Since all of us, whether human beings, animals and plants, all of us need water for our survival. We cannot exist without water. Water exists in all the three states, that is solid, liquid as well as gas. For the solid state, you already know that the ice that you are freezing in your freezers, and apart from that there are other forms like snow and frost. In the liquid state, we have water that we are drinking present in the lakes or rivers or well. Then apart from that, we have the dew, the tiny droplets of water that cover the leaves in the summer morning. Then we have the in the winter mornings. Then we have the gaseous state, that is the water vapor. Then the clouds, mist and fog are all examples of gaseous state of water. And water is also present in plants, animals and human beings. That is, it is making about 70% of our body weight. That is, it is a major component of all the living matter. It is present in all the fruits and vegetables, although certain things might be appearing to be dry otherwise, but they contain water. For that I had shown you an activity. Then what is the importance of water? It is used for bathing, drinking, cleaning, cooking food, everything. All of the life activities are more or less dependent on water only. So it is necessary for the germination, growth of plants and photosynthesis. It is a habitat for some living organism, that is the aquatic animals. It is used in industries for various purposes and so many other uses. Then I had told you about the sources of water. I told you about the rainwater, which is the purest form of water, and how we get this rain, and we should not take a first shower in the first shower of rain. We should not be taking a bath under it, which we generally like to, just because it contains impurities. Then I told you about the surface water, and which is of course including the river and lake water and ocean and sea water. Is that clear? So you already know about the rainwater, which is the purest form of water. And then talking about the surface water, which include the rivers and lake water, then the ocean and sea water. Now this river and lake water also contains many impurities and germs and is not fit for drinking directly. Then ocean and sea water generally salty, that is they are saline, and just because of this nature they cannot be used for drinking and irrigation. Then the underground water. Now this water is the water collected over the hard non-porous rocks which are below the surface of the earth, and they can be used by us. This form of water can be used by us for drinking and other purposes, whether be it agricultural and industrial purposes. Now springs are also a source of underground water, and the water contain dissolved impurities but no suspended impurities or germs. And this water also has certain medicinal properties, as it is very rich in minerals. Is that clear? Now I'll proceed on further today with the water cycle. We all know about the water cycle, isn't it? Water cycle is what? It is the continuous process, isn't it, by which water from the earth's surface and the other water bodies like the rivers, lake, ponds, big or small, oceans, seas, from the earth's surface is returned back to the atmosphere in the form of water vapor, and from the atmosphere it is back to the earth's surface as rain, hail or snow. So we can say that is the continuous process by which water moves from the earth's surface to the atmosphere and back, passing through the living and non-living parts of the environment. This is called as the water cycle. Now, what is the importance of this water cycle? That is, whatever water that we are getting as a in the why the water cycle is so important? Just because it is maintaining a regular supply of water to the earth's surface, and it is also regulating the weather of the earth, your planet. And the humans use water for drinking, respiration, perspiration, elimination of waste. Now, from where is this water coming? This is all possible through the water cycle only. We are needing water for economic activities like agriculture and mining, and food processing, and innumerable such activities. Where is the water coming from, and where is it being replenished from? It is through the water cycle only, isn't it? But what are we doing? We are discharging our waste into the main water bodies and polluting it also. Is it clear? So the water cycle is very important for all the living beings on earth, whether be it the plant or the animals. And there are three processes which are involved in the water cycle, that is evaporation, condensation and precipitation. So what is evaporation basically? So that is, you have studied this in detail in the earlier chapters, that the heating effect of the sun is doing what? It is evaporating water from the water bodies, that is the lakes, oceans, rivers, seas, ponds. And then plants are also giving this water vapor in the form of transpiration, that is, they are continuously adding up water to the atmosphere by the process of respiration, by the process of transpiration, isn't it? Then what is the process of respiration? So you have studied in biology what respiration is. It is by animals and plants both. So it is a process which is adding up water vapor to the atmosphere. So you can see that the glucose that is prepared in our body, that is synthesized in our body, or that is the food that is available in the body, and the oxygen that we are inhaling, they two combine together to give the products of carbon dioxide and water. Is that clear? So water is being added to the environment, it is being added to the atmosphere. And this is present also through the activity like the burning of fossil fuels also. So here you first the equation for respiration you have done in biology, that is glucose C6H12O6 plus 6 molecules of oxygen gives you 6 molecules of carbon dioxide and 6 molecules of water. And then the fossil fuels like are crude oil, natural gas, petrol, kerosene, these are all fossil fuels, that is basically the crude oil and natural gas and coal. Is that clear? So how are they formed? By the decomposition process under the effect of high temperature and pressure. Buried remains of plants and animals, for millions of years they have changed into the form that is available in the form of coal, crude oil and natural gas. So when we burn them, what do we get? We get carbon dioxide, and water is again added to the atmosphere. So both respiration and respiration and the burning of fuel is adding water vapor to the atmosphere. Then other processes which are involved in the water cycle are condensation. It is condensation, that is, it is a process by which water vapor in the air is changed into liquid water, right? Like if you leave the Then you have also studied about the process of condensation, that is the process by which water vapor in the air is changed into liquid water. You all know this, and you have seen this is the appearance of the glass when water vapor condenses, isn't it? The similar thing takes place at the higher altitudes, that is the air becomes cold. So initially what is happening is that the heat of the sun is evaporating and it is rising up, isn't it? And then after that it is changing into water vapor, that is it is rising up in the form of water vapor, and then the process of condensation is taking place at high altitudes, that is the air becomes cold and the water vapor present in air condenses to form tiny droplets of water. Now you can see this over here, that how because of the heat of the sun, the water vapor is evaporating, or the water evaporates, that is changing from the liquid form into the gaseous state, that is the water vapor, and then finally it condenses on the when it reaches in the higher altitudes, that is it rises up and changes into clouds. These water droplets along with dust particle, they form clouds. You can see these clouds, isn't it? And the source of other apart from the water vapor that has evaporated from the water bodies, the other sources I've already told you is transpiration, isn't it? That is from the plants also the water vapor is being lost. This water vapor is rising up in the air and then condensing again to form the clouds. So all these activities are helping in the process of formation of clouds, that is in the process of condensation, changing from the gas to the liquid form. And the tiny water droplets in clouds come closer and form bigger water droplets, isn't it? Then next is precipitation. Then water from these clouds, it falls as rain, hail or snow, isn't it? And this process is known as precipitation. So this rainwater again collects in the lakes, ponds and rivers, and then also it seeps into the ground and which we obtain as the groundwater, which we call the groundwater. So this cycle continues and keeps this water is replenished again and again, and so this is a continuous cycle. And then move on to the exercise for revision on page number 109. So the first question, which of the following is not a gaseous form of water in nature? It's clouds, mist, fog or frost. Of course it is, which one? It is frost. And frost is what? Frost is the solid form of water. So this is the answer. Which of the following is the purest form of natural water? Is it seawater? No, it contains salts. Then lake water is impure, and then the groundwater also contains certain impurities. So what is the answer? It is the rainwater, which is the purest form of water, natural water. Then the next page, page number 110. Next, yes, which of the following is saline water? Is it groundwater, rainwater, seawater, spring water? Yes, it is seawater. It is saline, that is salty. Then the reservoir water collected over the hard porous rocks below the surface of the earth is called, yes, surface water? No, it is groundwater. This is the answer. Then the source of underground water that contain dissolved impurities but no suspended impurities or germs, yes. Is it pond? No, not at all. Then rain, springs or river? Yes, it contains it is the spring. It is also a pure form of water. It just contains dissolved impurities but no suspended impurities are there, or no germs are there. So that is why it has certain healing properties also. So it is spring. Water from the clouds fall as rain, hail or snow. This is called, I've just told you, this is called precipitation. And please try to do the true and false, that is water regulates the body temperature. Yes, is it true or false? It is true. Seawater is fit for drinking. No, it is unfit for drinking just because it contains salts. Is that clear? So this is false. Then next is well water does not contain any impurity. This is also false, it does contain impurities. Then hand pumps and tube wells are used to pump out groundwater. Yes, this is true. Water cycle maintains the supply of water in land, also regulates weather on earth. Yes, this is true. Then water, a compound. We have already studied when I was telling you about the atomic structure. I had told you how water molecule is formed. It is by the sharing of electron between hydrogen and oxygen. So I need not recapitulate it again. That is by the sharing of electron, and it forms this water molecule is formed by the sharing of electron between two hydrogen atom and one oxygen atom. Hence the formula is H2O. So you have these two, you can see a hydrogen, and this is oxygen atom. This is also known as dihydrogen monoxide. Is it clear? This is known as dihydrogen, that is two hydrogen are there, two hydrogen atoms means dihydrogen. Monoxide, mono means one. Is that clear? One oxygen atom. Is it clear? This is known as dioxide. So otherwise only one O is given. I have just divided into two parts, that is why I have just added 2O. It is just a single O. So this is also known as dihydrogen monoxide. I have also discussed about the molecular mass of water, that is 18 AMU, that is 18 atomic mass unit. This I have already told you. So which scientists were involved in the discovery of this particular compound? That is Henry Cavendish in 1781 proved that water is a compound. So Henry Cavendish in 1781 proved that water is a compound made up of hydrogen and oxygen, and later Lavoisier supported Cavendish for the same. Is that clear? So I've just shown you that one molecule of water contains two atoms of hydrogen and one atom of oxygen, isn't it? So the ratio of hydrogen and oxygen in water is 1:8. Is it clear? The ratio of hydrogen and oxygen is 1:8 by mass. So you have to remember this. This is 1:8 by mass, that is 1 volume of hydrogen and 8 volumes of oxygen. So when an electric current, I have told you that how water is split up. It is by in the last chapter I told you about the process of electrolysis, and I had told you how water splits up into its constituents, that is hydrogen and oxygen. I have discussed this earlier, that is when an electric current is passed through water which is acidulated, that is this acidulated water means what? Acidulated water means that it contains a few drops of dilute sulfuric acid, I beg your pardon, contains sulfuric acid. Now in order to make it a good conductor of electricity, this water is acidulated, that is it contains a few drops of sulfuric acid, dilute sulfuric acid, in order to make it a good conductor of electricity. Is it clear? So that the process of electrolysis can proceed properly. So what is the reaction that is taking place? That is 2H2O. This water splits up into its constituents H2 plus O2 by the passage of electric current. Is that clear? So I have told you about the anode and the cathode also, that is the positive electrode and the negative electrode, and how hydrogen is obtained where and oxygen is obtained where. I have discussed in the last chapter. I'll just revise it once again, that hydrogen and oxygen are collected at cathode, that is the negative electrode, hydrogen is collected, and at the anode, which is the positive electrode, oxygen is collected. Is it clear? So this is how water is split up by the passage of electric current. Here you can see an electric current is passed, otherwise this is not possible. Water does not split up by any other means, whether you heat it at a high temperature or you mix any chemical with it. It will just split up into its constituent atoms, that is the oxygen and hydrogen, by the passage of electricity, that is by the process of electrolysis. Is that clear? And I have also told you about identifying these gases. So hydrogen is identified how? That when you bring in a splinter, burning splinter, it burns with a pop sound. Is that clear? And how do you identify oxygen? It is by a glowing splinter burns into a flame in oxygen. Now this you can see for confirming the presence of a hydrogen gas. When you bring a glowing splinter like this near a test tube which contains hydrogen, this splinter will burn with a pop sound. It will burn with a pop sound, which I have earlier shown. Pop, a characteristic squeaky sound will come out. Is it clear? And then similarly, the confirmatory test for oxygen. When you bring a glowing splinter inside a test tube which contains oxygen, it will rekindle, it will glow again. Like for instance, agarbatti, when you glow it and then you leave it just glowing it, isn't it? And then you bring such a thing inside the test tube which contains oxygen, it will start burning again. It will be rekindled again. So this is what confirms the presence of hydrogen and oxygen gas. Coming to the physical properties of water, all know that water is a colorless and tasteless. It has no taste, and odorless, that is, it has no smell, and transparent liquid, isn't it? Then the boiling point of pure water is 100 degrees Celsius, and the freezing point, of course, is 0 degrees centigrade, Celsius or centigrade. Anything that can be 0 degree or Celsius or 0 degrees centigrade. And these two temperatures are under normal pressure of 1 atmosphere or 760 millimeter of Hg. So that is the millimeter of Hg is the unit of pressure. Is that clear? So this change in pressure and addition of impurities affects the boiling point of water. That is, if the pressure is changed, it is decreased or increased, or there are impurities which are added. For example, salt is added or sugar is added to the to water, then what is the effect on the boiling point? So you will see over here how the water boils, and then when you add some impurities to it, and then what is the effect? So you can make your prediction that what's going to happen to the temperature when we add 2 scoops of salt to it. Then what do? You just add 2 scoops of salt to it, then you will see the effect on the temperature, that is from 92 degrees Celsius over here, that is if it changes to 97 degree. That is when we add impurities, the boiling point increases. Is it clear? Now again we can see the effect of pressure on the boiling point of water. We have the flask which is filled 3/4 with water, and there is a stop cock which is used to release the heat. So what do? We keep boil the water, and then we observe the reading in the thermometer, and after that what do we see? That the boiling point of the water is, you can see this reading, it is 100 degrees centigrade, and when this stop cock is released, that is the steam is out, and what happened? It is decreased, and then after that again the stop cock is switched on, that is all the steam is inside. There is a further increase in the boiling point, that is increase in the boiling point happens when there is an increase in the pressure. Again, when we cool the flask, that is the temperature is brought down, there is a decrease in the boiling point, the temperature falls, and then what do we see? That boiling point of a liquid can be affected by the increase and decrease of the pressure, that it increases with the increase in pressure and decreases with the decrease in pressure. Is that clear? So this finds an application. This is used in pressure cookers. That is, it is easier to cook food in a pressure cooker than an open vessel. How? That is, what is happening is, when the pressure increases in the pressure cooker, the boiling point also increases, hence food inside the pressure cooker gets sufficient heat before the water boils. This makes the cooking easier and faster. Is it clear? So similarly, in hilly areas, what is there? The pressure is less. That is, the air is less dense, hence the atmospheric pressure is less. So as you move on higher to higher altitude, the pressure keeps on getting reduced or it decreases. So the pressure is reduced compared to the sea level or below the mountains. So over there the water has a lower boiling point. When the water has a lower boiling point at higher altitudes, it will take a longer time to cook in hilly areas. That is why what is happening, the cooking takes longer time to cook. That is, any food takes comparatively a longer time for cooking. Is it clear? So we'll discuss about the freezing point and other properties of water in the next lecture, inshallah. Allah Hafiz.